The next couple of lessons will focus on actors. So I want to begin this lesson by talking about the coding standards, and again I'm in the Unreal Engine documentation. This is very useful, you can give this a read. It talks about why code conventions are important, such as the fact that 80% of lifetime cost of a piece of software goes to maintenance. Okay, stuff like that. Alright, then I'd like to bring your attention to the naming conventions. The first letter of each word in a name, such as a type name or a variable name, is capitalized. Alright? There's usually no underscore between words, so we do not want this kind of stuff. You can do UPrimitiveComponent, you can see camel case, but the class or variable name and stuff also starts with that P. Then of course you've seen U, so UObject for example. You can see type names are prefixed with an additional uppercase letter to distinguish them from variable names. So you have a few things that you can take a look at. Template classes are prefixed by T. Classes that inherit from UObject are prefixed by U. We've seen this already. Then you also have classes that inherit from actor are prefixed by A. So of course an actor is a UObject or an object, but if it is an actor, so if it derives from actor, then we will also put an A in front of that class name. Okay, this is basically what this is about. You have a bunch of other things here. You can see enums are prefixed by E and so forth. Okay, you can give this a read and use this as a reference as you develop. Okay, so I have my C++ experiments project open again. I'll just go to File, New C++ class, and I'll choose Actor. You see I have a bunch of other things, character, pawn, and so forth. Now an actor is again something that can be spawned or placed into the world, into a level. I'll click Next. I'll call this very interesting actor. Now this is simply a silly actor that we're going to write. It's not going to do anything specific here. It's just going to float around. So in that case, you can probably call it floater or floating actor or something like that. But in this case, we're just being silly and we're kind of having fun. So I'll call it very interesting actor. I'll click create class. You'll also notice it will compile C++ code when you add a new class. It will show you all of this stuff. Added new class, loading Visual Studio, auto reload complete, and all of that. So here it's loading Visual Studio again. Okay, so we'll talk about all of this stuff in just a bit. But what I want to do is I want to go to the header file. And you see that we called it very interesting actor. And you'll notice once again that we don't have to add the A. As I mentioned previously, if you inherit from actor, AActor, because even that has that A in front of it, then you need to prefix your type or your class name with an A. You can see that Unreal will do this automatically. Okay, so back in the editor, another thing I'd like you to note is I can now left click and drag and drop this into my world. Even though you can see I can drop a couple of those in my world, I can also right click on this and create a blueprint class based on that actor. I'll just do blueprints, my very interesting actor, underscore BP for blueprint. And similarly, again in the blueprints folder now, I'll just save all of that stuff. Now I can drag and drop these into the world as well. So the reason we can do that, and I'll go back to the C++ folder. With the UObject, you remember I cannot go and right click on this and create a blueprint unless that is blueprintable. The actor, if I go into C++, you can see in the U class, we don't have any specifiers, right? So you might think, okay, that's interesting because I can create a blueprint from this. So why is that? Well, you can right click on actor and then I can go to definition, and to the right here you'll see it opens up this tab in this document section, and I'm here at this declaration basically of the actor, AActor, and you can see this derives from a UObject. As I mentioned, actor derives from UObject or is a UObject. even though it does not get that prefix of U. So you can see U class, blueprint type. The point is we can create blueprints based on our C++ actor classes without having to go and specify that in U class, in that U class macro, because it's already done in the definition of AActor. So basically we are inheriting that functionality. Just to try and make sense out of that. Quickly here I'll go in and remove all of those instances. Okay, a couple of things that you might notice here. If I left click and drag and drop this actor into my world, you'll see that we don't get a transform like we do if I left click on the chair, for example, we get a transform. Okay, so I'll search for that, and you can see if I left click we don't have that transform. If I left click on a chair again, you'll see we get transform, static mesh, materials, all that stuff. But the instance of our very interesting actor does not have a mesh or anything like that, or a handle show up. Also, if I left click on this chair, for example, and I press F to frame up on that, or I go in the world outliner and I double click on that, an object, I can frame up on that. Search for my very interesting actor again, double click on that, you can see that we don't frame up on that. I can also press F. That's because it's kind of in my world. Okay, you can see it in the world outliner, but we don't get handles or anything like that. That's because we have not set up a scene component or anything. We do not have a default root set up yet. So I'll just select that and press delete. Delete that from my world. Now if I go to blueprints and I drag out a very interesting actor, okay, the blueprint of a version of that, you can see that the handles do show up. And again, I can press F to frame up on that, or I can double click on that to frame up on that as well. So let's open that up, okay, that blueprint, to see what's going on. And I'll click open full blueprint editor. So what we can see is we have the my very interesting actor underscore BP self. You can see the class, and we can see the parent class. The parent class is very interesting actor, the C++ class. So this inherits from that. And here you can see this thing shows up. This is the default scene root component. This cannot be copied, renamed, or deleted. Alright, so what we can do though is we can replace that. So this has a scene transform. So what we can do is we can add components by clicking in this drop down, and then we have a bunch of components. You can see we have meshes, for example, basic shapes, and so on. So if I have a cube, I'll go to the viewport tab, and then you can see this will show up. I can add another component like a sphere. I can move that around. Okay, I'll compile and save this, and I'll go back over here, and you can see this shows up. Okay, those components show up, and I can move that thing around. The default scene root, you can see, has this transform. Again, I can move that stuff around. I can also go in here and select individual components. So this cube, I can move that around. The sphere will follow because that is a child of that cube. If I move the sphere around, that will move independently. But the point is, if you create a blueprint actor, this will come with that automatically. Right, an actor needs some component, some root component. I'll drag and drop this over here, let go, and you can see that the sphere is no longer a child of the cube. What you can also do is you can make the cube, for example, you can make that the root component. So I left click and drag and drop that. Okay, and you can see drop here to make cube the new root. The default root will be deleted. So now we have an actor as the root as opposed to a scene component. So if I compile and save this again, I can probably just save, and you can see what my actor looks like now in the details. If I move that cube around, everything moves along with that. So that is now the root. So as we've seen a second ago, we can have an actor in the world that's empty, that basically does not have anything. And we can then go and add through components. We can add things like static meshes, such as a sphere or a cube. We can also add lights and various other things to our actor, again through components. We can do parent-child relationships, as we've seen. So if you move one component, you can have the children of that component move with it. So in the documentation again, I can do a summary of this in a slide or something, but I feel like this is fairly concise and does a good job of explaining what's going on. So I'll link you to this. So you can see components are a special type of object that actors can attach to themselves as sub-objects. Okay, then you have a bunch of different types of components. Now UActorComponent is the base class for all components, and you can see everything the player sees or interacts with in the world when playing the game is ultimately some type of component. So you have actor components, which are most useful for abstract behavior such as movement, inventory, attribute management, and so on. Actor components do not have a transform, meaning they do not have any physical location or rotation in the world. Remember I talked about the scene component, and we'll actually see how to do this in C++ shortly. But you'll see that here actor components are UActorComponent, okay, class UActorComponent. Then the scene components are class USceneComponent, a child of UActorComponent. You don't have to worry about the inheritance all that much at this point. With time, as you spend more time programming stuff in Unreal Engine, you'll start to remember some of the inheritance and stuff. But the documentation is useful, okay, if you want to check that out, as you can see right here. Now, scene components support location-based behavior that do not require geometric representation. Cameras, physical forces, constraints, and so forth, even audio. Okay, then you have primitive components. This is UPrimitiveComponent, a child of USceneComponent. These are scene components with geometric representation, generally used to render visual elements, or to collide or overlap with physical objects, so static or skeletal meshes, and particle systems, capsule, and sphere collision volumes, and so forth. Okay. If you scroll down, you have even more detailed explanations of what's going on. Scene component is an actor component that exists in a specific physical position in the world, defined by a transform. Okay, the position is defined by transform, and a transform you might think of as XYZ, but actually a transform consists of three things: location, rotation, and scale. Now you can see here that actors can designate a single scene component as root, meaning that the actor's world location, rotation, and scale are drawn from that component, right? Of course, I'm not going to read everything for you. I'm just kind of highlighting a few important things here. Okay, what I'll do is I'll delete this instance of my very interesting actor. I'll actually go in here and I'll delete these components. So we have the default scene root component. This will generate this default scene root component as soon as you delete. I'll just Control Z to undo. You'll see we have this cube now again. Okay, we set that previously as the root. So if I select that, press delete, you'll see that will generate this default scene root again. And now we have this, and that's simply an indicator so that we can see where this thing is in the world, since it doesn't have a static mesh or anything like that. So there's some visual representation. Okay, so I'll just save that. So basically I'm reverting this thing back to what it was before. I'll minimize this and I'm back in Visual Studio. So what we want is in the public section, again, I'm in the header file, we have U class here, okay? And so in the public section here, I'll go and do USceneComponent, that is a pointer, and I'll call that root. Now, there's a pointer because we will be using create default sub-object, which will return a pointer or basically a reference to whatever it is that we instantiate. So basically whatever the object is that will create. So we basically have a handle to that. Okay, so let's just see how we do this. We have the constructor right here. So create some space and I'll do root equal to. Here you can see the IntelliSense is actually trying to help us here, create default sub-object. And this is a template function. What we do here is we pass in what it is that we want to create. And this is, again, USceneComponent. what is the type of the object that you want to create basically? Well, it's a USceneComponent. Okay, again, this is a template function. Here what we can do is we can specify the name using the text macro. I'll just call that root and add a semicolon at the end. So again, this here is a macro. You have to also enclose that in parentheses. Okay, so just make sure about that, otherwise you'll get web problems. And so as you can see, we do not use a new or any of that stuff. We use this create default subobject template function. We pass it the type that we want to, of the object that we want to create. And here we give it a name. Now we are not quite done yet. What I want to do is I want to set the root component. So the root component is the root. This subobject that we just created, that will be the root. Okay, and this component that we set as the root component is very important. This will define the transform, so the location, rotation, and scale of this actor. So this is very important. And then other components you want to attach to this. So of course this can be something else as well, like a static mesh component or something like that. But in this case, this is a USceneComponent as you had it in the example where we have that instance of the blueprint. Now in this case, we've created this manually in C++. Okay, so I'll just bring back Unreal Editor here and I'll compile this. So that compile is complete. If I go to the C++ experiments folder here, so my C++ classes, I can left click and drag and drop one of these very interesting actors into my world. And now you can see that we kind of get this transform handle and we have the transform. Another interesting thing is if I open up the blueprint again, you'll see that this root scene component, you'll see source, inherited, C++, introduced in very interesting actor. And if I go and add again something like a sphere, and I want to make that the root component, I can left click and drag and drop. I can try and make that the root component now, but I cannot do that because this thing is now defined in C++ to be the root component. So it's explicitly specified to be the root component. So I'll just go and delete this very interesting actor and I'll drag and drop a blueprint in here. I'll save all, drag and drop one of these in. You can see that I can move that around and everything. But if I select the root component and I drag that around, you'll see even though the handle moves around, that does not update the transform. Okay, will not update as I drag my handle around. That will actually reset as well if you left click on the actor itself and then on the root component, you'll see that handle will actually reset as well. If I move the actor, then of course I can move this around. Okay, I'm back in Visual Studio and I have the very interesting actor.h file open. What we need to do is we need to add the U property macro, and as specifier we need to go and add visible anywhere specifier. Now in the next video we'll talk about some of these specifiers in more detail. As a beginner, if you go and look at the documentation, you might go and add edit anywhere or something like that, but there is differences. So here we have this, okay, and this is a pointer. So we don't want to edit the pointer. Okay, as we'll see in the next video, you can if you want to set defaults that way, but we want this to be visible anywhere. And then basically what will happen is the component will be visible and we'll still be able to edit, okay, what is available on that component. Even though this is not edit anywhere or something like that, we'll still be able to edit what is on the component because that will be visible. Okay, this does not determine what is editable or not on the actual component. This kind of relates here to this property, and in this case, this is a pointer. So more on that in the next video. For now, we want this to be visible anywhere, and I'll build this. Okay, so I have Unreal Engine open again. In the C++ classes, you can drag in one of those actors, and you can see that the transform shows up. So when we have the very interesting actor itself selected, okay, that instance, it will draw the transform from that root component. So you can see if I move the root component around, you can see the location, for example, 70 and 360 and so on. And that is reflected as well if you have the actor itself, okay, that top one selected. You can see that these two are the same. So that relates to movement as well as when you go and rotate this thing around. Okay, you will see whether you have the scene component or the actor itself selected. The transform will be the same, so the location and the rotation will be the same. That again is because the actor draws that transform from the root, whatever you specify as being the root.